And I'm Lily Chiu. I'm a professor at UT Austin. It is my great pleasure to chair the next session. We have a wonderful group of panelists who are going to share their thoughts on 5G and edge applications. We have 4 panelists. Bohan at George Mason University, Derek Brown, Head of Telecoms and Mobile at Cambridge Consulting, John Smith, a VP at Qualcomm, Ganesh, a principal researcher at MSR. They all have remarkable achievement both in research and tech transfer. So what we are going to do in the next hour is we will first have each of these panelists share their thoughts about their fascinating research, as well as introduce themselves briefly. They each will have 7 minutes. Then we will go around the table and open up for Q&A. And we are going to go in the alphabetical order of first name. So first, let me have Bohan to introduce his research related to 5G and edge applications.
Yeah, sure. I prepared the slides, so I think I can share my screen, right? Okay, great. Can you see my slides?
Yeah.
Okay. Yes. Okay, great. Hello, everyone. I'm Bohan. Thank you for inviting me for this panel. So it's a great pleasure to be here and share with you my experience on edge computing and its applications. I actually just joined George Mason University last month. So what I'm going to talk about will be mainly the work I did at AT&T Labs Research. For my own research, I'm doing systems research, mainly on network systems, mobile computing, and wireless networking. So in the recent several years, I have been working with my collaborators on mobile immersive computing. It's an interdisciplinary research. We are working with researchers from computer vision, computer graphics, multimedia, machine learning, to improve the network efficiency and the quality of user experience for this type of emerging applications. So edge computing is a computing paradigm that moves computation and data storage closer to end users. When talking about edge computing, the first thing I usually do is to define it. Otherwise, we may discuss completely different edges. I have seen lots of definitions of edge computing. For example, I have heard one definition that edge computing is a computing that is at least one wireless hop away from end devices. Clearly, this is a definition from the end user's perspective. From the service provider's perspective, edge is anywhere that's not in their core network. For an extreme case, our mobile devices such as smartphones and tablets could be the network edge. So I think we can roughly divide the edges discussed in research papers and online articles into 2 categories. The first category is about edge devices. For example, we can run Azure IoT Edge on this Raspberry Pi. And also we can have a more powerful edge camera running on top of the NVIDIA Jetson developing board. So another category is about the edge services that are offered and managed by cloud service providers, cellular network operators, and internet service providers. For example, they can deploy some edge service on Wi-Fi access points or on edge servers co-located with cellular towers or in the central office. So my own research mainly focuses on leveraging the edge services to improve the quality of user experience for mobile applications, especially the mobile immersive applications. My research project started to leverage ad computing when I worked on mobile augmented reality, AR. We saw 2 interesting papers on mobile AR yesterday. AR enhances a real-world object with overlaid perceptual information by leveraging computer vision algorithms such as object detection, object classification, or object recognition, which are all computer intensive. So one challenge here is that the end-to-end latency for mobile AR may be high. One possible solution is to offload the compute-intensive tasks to the cloud. However, the latency from the end user device to the centralized server may be high, and also the link may not be stable. So we proposed the Jaguar to leverage ad computing to reduce mobile AR latency. Jaguar features flexible, robust, and context-aware tracking. For example, we can track the recognized object inside the camera view when the mobile device moves. It also features accurate and low latency object recognition at the mobile edge through GPU acceleration. So I'm currently working on the scalability issues of edge offloading because we found that usually a single GPU card can handle only the requests from tens of users. So the takeaway here is that AR can leverage ad computing for reduced end-to-end latency. The other application I'm working on that heavily utilizes ad computing is immersive video streaming, including 360-degree video streaming and volumetric video streaming. 360-degree videos capture panoramic views. When watching a 360-degree video, a viewer can freely change the viewport by moving the head around. The key challenge here is that we need to deliver a huge amount of data to end users. So we propose the viewport adaptive video streaming to improve the efficiency of 360-degree video streaming. Lily has also done some great work in this area. So the key idea is to deliver mainly the video content that will be consumed by end users through viewport prediction. For the papers published in this area, they can deliver 360-degree videos up to 8K. However, there were studies showing that a human with normal vision can perceive 60 pixels per degree. This means that the resolution should be 8K for viewport content and 16K for panoramic frame. So far, no existing solution can deliver 360 videos with such a high definition. Even for our previous work, Flare, that was published in MobiCom 2018, decoding these ultra high definition videos will lead to frequent video stalls, rebuffering on mobile devices. So one of my ongoing projects leverages ad computing to enable high performance video transcoding and deep learning based viewport prediction. For example, the client can send a video request along with viewport trajectory, and using a predefined deep learning model, a pre-trained deep learning model, the ad cloud can predict the future viewport and request the viewport content in tiles from video servers. After getting these tiles, the ad cloud can decode, renders, and merge the tiles into a single video stream that will be delivered to end users for display. I have another ongoing project on volumetric video streaming that also leverages ad computing to render 3D models in volumetric videos into 2D images. So as we can see, immersive video streaming can take advantage of ad computing for reduce the computation overhead on mobile devices. In terms of ad computing in 5G, I think the first question you may have is what 5G can bring to ad computing? The answer is tied to the 3 key pillars of 5G, URLLC, EMBB, and MMTC. So URLLC here stands for ultra reliable low latency communication. EMBB is enhanced mobile broadband. MMTC stands for massive machine type communications. You have known from the keynotes that 3GPP really lacks acronyms in their standard. So I think ad applications can benefit from 5G for low latency, high throughput, and large scale. For example, AR can take advantage of the extremely low latency. For immersive video streaming, if the bandwidth is high enough, we do not need to perform viewport prediction. We can just ship the entire video to users. And also the IoT devices can benefit from the scale that's supported by 5G. Another frequently asked question of 5G and ad computing is how to do experiments. The good news is Amazon just launched the Wavelengths, ad computing service that's embedded in the 5G ad of Verizon networks. However, this service is only available, I think, in 2 cities, Boston and San Francisco. If you are lucky, if you are close to these cities, you can do some real-world experiments. Otherwise, I think you may resort to trace-driven emulations. So I have measured the performance of 5G networks with my collaborators at University of Minnesota. So we make our data set publicly available. So if you want to try some application on 5G using ad computing and do not have access, maybe you can run some trace-driven emulation. I think I may run out of time, so I just stop here. Thank you.
Thank you very much, Bo. Next, we'll have Derek Long, head of telecom and mobile at Cambridge, to share his perspective.
Okay, thank you very much. Hope you can all hear me. So my name is Derek Long. I'm head of telecommunications and mobile at Cambridge Consultants. Just a few words, because I would expect that not many people know who Cambridge Consultants are. So we are a technology design consultancy. We're based in, and I'll explain that in a second. We're based in Cambridge in the UK, and we have other locations in Boston, Seattle, San Francisco, Tokyo, and Seoul. And
Derek, sorry to interrupt. Would you like to turn on your camera?
Oh, I'm sorry.
No worry.
There we go. So you can see me. Yes, yes, we have about 900 people based in these locations. The work that we do is, so we're a technology design consultancy. So our customers come to us and they ask us to build so technologies and systems which they cannot buy elsewhere, which have to have a particular, and the emphasis is on high performance, which cannot be gained elsewhere. So I can, although we're maybe not very known and very well known, and we're not very big, I am sure that everybody listening to this panel have come in contact with our intellectual property at some time. We have been very involved over the years with the development of Bluetooth, and in fact, a company called CSR, which was bought by Qualcomm some years ago, was a spin-out from Cambridge Consultants. We also work and develop technologies for the Iridium satellite constellation, and something which is so especially relevant in the context of edge computing is we developed the radio connectivity platform for a how can I say, a manufacturing and logistics solution, which is run by a company in the UK called Ocado. In North America, I believe the company which implements it is Kroger Supermarkets. So we develop high performance technologies, and this is really the kind of the focus, and for what we're going to talk about later with 5G and edge computing it is all around how these two technologies enable the kind of deployment and implementation of high performance services, right? So As Bo said previously, we have massive machine type communication, we have mobile broadband for best effort, and we have URLLC, which defines qualities of latency and reliability. So when we look at the kinds of things that we build, we are looking at how can we deploy a service which has where we require a low latency in order to implement it. So and this means that we can integrate a user device or a application on a user device have a very tight integration with the network side, and of course there we can locate this in the edge. Excuse me. We also look at this where we want very good resource efficiency, where cloud implementations which are located in a central place are either have too long, they might be more cost efficient, but they have too long latency times, and also there is a high resource usage in the network, which then has a cost implication. Also we look at applications where, let's say, where we're trying to optimize the end user equipment. So the obvious example there, also picking up on something Bo said, was with augmented reality. If you want to have, just to illustrate, if you want to have spectacles that provide you with some kind of augmented reality, you don't really want to have all the processing for the augmented reality in the spectacles. There's not the space and there isn't the battery, and then you also end up with a very expensive pair of spectacles. So it is better, if you are approaching a challenge like that, to use the capability of the network edge and put the compute into the network edge. So that is let's say a user service kind of example. We are also looking at how to utilize the edge compute facility in order to provide superior network functionality as well. One area which we'll come to later when we talk about 6G and research and so on is the development of more improved antenna systems and the increased compute capacity that is required for signal shaping, beam steering, and beam forming in order to get the kind of air interface efficiency that you were looking for in future networks. So that's just a quick overview of who we are and what we do. Thank you.
Thank you so much, Derek. Next, we'll have John Smith, VP at Qualcomm, to share his research perspective.
Yeah, thank you very much. I'll just pull up my slides here. So I want to talk a little bit about enabling the 5G edge. And so when we look at the 5G technology evolution, so I'm heading up the research at Qualcomm from 5G into 6G, and we really began 5G obviously in release 15. And we looked at that transformation of new approaches that differentiated 5G from 4G. And a lot of that transformation related to how are we going to enable new services, new deployments, the role of edge compute, as well as obviously the evolving aspect of mobile broadband. And so 5G really expanded as we went from release 15 into release 16, as mentioned by some of the other panelists as well, enabling things like ultra reliable, low latency communication and the expansion into IoT. And this is continuing in release 17, which has already begun standardization globally, and into release 18, 19, and 20 and beyond. When we look at the advantage and opportunities of 5G, it really is expanding the ecosystem. So consider things, whether it's construction and mining, digitizing education, smart manufacturing, intelligent retail, and richer mobile experiences. A lot of these use cases involve the edge. And that's why I think today's panel at MobiCom is an exciting opportunity to talk about that intersection of 5G, how 5G networks are deployed, and how does that intersect where computing occurs. And a good way to look at that framework as well is the evolution of the network itself. So we're moving from a traditional RAN architecture in terms of baseband processing and radio units, and evolving from a centralized RAN all the way to a virtualized RAN. And why this is important is because it enables a wider range of use cases and then also more optimized partitioning. So in terms of where compute is occurring, where is the communication occurring, even what frequency bands are we using? What's the density of the network? Is it a millimeter wave based small cell network that's leveraging the advanced opportunities at bands like 28 gigahertz and 39 gigahertz, and later on 60 gigahertz and above? Or is it also something that's about the wide area mid-band spectrum like 3.5 gigahertz, 2.6 gigahertz, as well as low band FDD? So the power of virtualized RAN is that it enables a more cost-effective deployment, and it also enables partitioning and new entrants into the infrastructure industry. And when we look at this intelligent edge, it's not only about the communications and the computing side, but then also the incredible, powerful role of artificial intelligence and machine learning. So AI and ML combined with 5G, because that further enables not only device processing in terms of low-powered compute, inference at the actual device itself, but then also what's happening at the edge of the network and what's happening in the deep cloud. So things like privacy and security, immediacy for low latency applications like augmented and virtual reality, all of a sudden the full delivery of opportunities with 5G leverages this powerful intersection. And at the same time, as we're bringing together virtualized RAN and edge compute, then all of a sudden we have an even more powerful combination where it's not only AI and 5G, but also the aspect of edge compute and virtualization. So I think this is going to be an exciting panel today as we're talking about this intersection and how does that relate to all these different opportunities. Thanks very much.
Thank you so much. And next we will have Ganesh to share his thoughts on this interesting topic.
Can you see my screen? Can you see my screen?
Yeah, we can see, but it's not in the presenter mode. We see your next slide as well.
Oh, okay. Give me one. Is it? You see it in presenter mode now?
Yes, yeah, that looks good.
Thank you. Hi, thanks for the opportunity to be on the panel. I'm Ganesh. I'm a principal researcher here at Microsoft Research up in Seattle. I've been here for a little over 7 years now. I generally work in large-scale systems, cloud systems, big data analytics, and so forth. And the last couple of years, I've been focused on edge computing and an application actually that acts as like a key driver for edge computing, and we believe as a key application for 5G as well, video analytics. We got into video analytics primarily because it acts like a great stress test for a whole bunch of aspects, including the compute available at the edge and the cloud, the connectivity to reach the edge and the cloud, the amount of data volume, and needless to say, the privacy sensitivities as well. Yeah, so a startling statistic in terms of cameras everywhere is that there's actually a camera deployed for every 8 people, in the US. And so with this large amount of cameras, of course, a whole bunch of applications get done. We've tried to use a couple of applications. So I'll start off by motivating a quick couple of pilots that say we've done. One of the things that we'd worked was we'd call this video analytics towards Vision Zero, where the idea was that let's use cameras to the widely deployed cameras to make sure that we can make traffic on the road move more smoothly and move more safely as well. I'll just show a small video of what we have. This was work where we've done with a collaborator with a lot of cities as well worldwide. Oops, I'm not sure why this video doesn't play. Okay. Okay, it looks like the video is not playing. But the whole idea here was that we go ahead and monitor the traffic intersections live, the camera feeds. And what we do is we detect objects in the view, at various parts. If there is somebody with like a wheelchair or someone that needs some assistance at the edge of a crosswalk, then we automatically control the traffic light and turn it on. And as the person is crossing, if we see that the person needs a few additional seconds to finish crossing, then we detect that and then send a signal to the traffic light that extends the light as well. There's supposed to be a demo video of this. Too bad that's not playing. Another application as well is in the smart city zone that we've been working on parking lot monitoring, where again, parking is something that essentially has a lot of implications in terms of where we go to. The amount of time needed to find a parking slot, the congestion that it causes, needless to say, the emissions and so forth along with it. So we've been working with another partner where we use these cameras that are connected by millimeter wave networks, do the analytics mostly on the edge box with an option to go to the cloud when required to sort of like have real-time parking dashboards. With these applications, I guess right from the beginning when we started, we saw video analytics and edge computing as going hand in hand. And we saw video analytics and edge computing going hand in hand for three reasons that would sort of like also be apparent from the applications that I mentioned, which is the amount of data and the network bandwidth to reach the cloud, the being able to function when the uplink to the cloud is disconnected. This is a common problem, and this is something that does worry a lot of the people that deploy these video analytics applications. And the final thing is the privacy of videos, because these videos often contain sensitive information around license plates, faces, and so forth. In fact, as you would see, a notable omission in this list is low latency. It's not because I don't believe it's not important, but in a recent article as well that we wrote in SIG Mobile, Get Mobile, is that our survey of video analytics applications, deployments generally seems to suggest that these three are the main reasons why folks want folks want edge computing for video analytics. It seems less to do with the latency as such. So I would say those applications, I guess, need sort of like more work to get into the mainstream. So we've recently open sourced a Rocket video analytics platform. So the links there will provide you, will lead you to the GitHub repo for you to go ahead and play with the code. So I encourage you to play with it. If you have any feedback and so forth, please let us know. So I wouldn't touch upon all the aspects that we worked on in it, but generally you would see across the spectrum that it spreads from compute efficiency to network to the cloud, and some of the recent aspects around how do you do video analytics on a continuous basis where the models have to be trained, as well as say over multi-hop millimeter wave networks. I will skip some of these details in the interest of time. And finish with some of the open problems I thought in this space that is important, in that we need the ability to be able to split these video analytics or data analytics pipelines broadly across these hierarchies of edge computes and the cloud that's going to be typical of 5G deployments. Privacy is a big thing, and we need to think about what opportunities edge compute presents to us. And finally, platform abstractions for applications to be deployed across this 5G platform so that they can automatically deal with bandwidth fluctuations, disconnections, and so forth. With that, I'll stop. Thank you.
Thank you all, the panelists, for sharing so many fascinating edge applications that can benefit from 5G. And given 5G standard is set and the deployment is ongoing, what kind of 5G capability you would like to see but not there yet in order to support the type of edge application you are interested in? So what are the open research for PhD students to look into to better support these new generation of edge applications? We can also go around in the order of in the alphabetical order, and then each time we will slide by one slot.
Okay, then I can start first. You mentioned what are the features that I want to see there, but it's not there yet. I think I can share my experience. When we measured the 5G network last year, I was particularly interested in the latency because 5G NR, they claim that the air interface latency could be around 1 millisecond. But our measurement study shows that the latency was quite high, almost the same as 4G LTE latency, just slightly lower. I think one of the reasons was that at that time for 5G deployment, they still use the non-standalone mode. So for 5G, the RAN network will share the core network with LTE. In that case, even if the wireless link can achieve a low latency, but in terms of the end-to-end latency to the internet server, it was still high. So I hope that with the standalone deployment of 5G, we should be able to get a low latency. And you also mentioned the research challenges, right? So to me, the most important open research problem of edge computing are the manageability and scalability. So given the distributed nature of edge computing, I think the footprint will be much larger than the central cloud. So in cellular core networks, we have only tens of data centers to support and offer the service. But for edge services, we need thousands of smaller data centers, for example, in the central office to host the edge servers, because we want the services to be closer to end users. So managing these edge servers and also offer the edge services, I think is a pain. Also about the scalability. So I have seen lots of papers talking about we can offload the computer intensive tasks to the edge. But in terms of the evaluation, the skills are all small. Again, given the distributed nature, so edge service providers may not be able to provision a huge amount of resources on edge servers. So how to make the edge service scalable during peak hours and how to guarantee the service level agreement. I think this is still an open research problem. Yeah, I think that's all I have.
Very interesting. Derek, would you like to share your thoughts?
Yes. Okay. So some thoughts. So the first one, what's missing, and I have to say, I know work is being done in the area I'm about to talk about, but it's still currently missing. I think so we are in contact with a lot of customers with users of telecommunications networks and vendors of telecommunication networks and operators as well. And what's becoming clear is that there are an increasing number of environments where let's say the standard cellular architecture is no longer the most cost-effective solution to providing coverage and connectivity. And that if I take an example, rural areas is a classic example where it's very hard to get a good return on the investment that an operator makes in this area, and this incremental efficiency improvements and cost reductions that we've seen, this is going to reach a limit if it hasn't already reached a limit. So new architectures are required in order to do this. The one that I'm referring to that is already in progress is non-terrestrial networks in this sense. But I fear that the work that's being done in non-terrestrial networks is really so it's not for the high performance type connectivity at this point. It's so this is an area which I think is a good place to kind of focus some activities. And then to your second question here about research areas, I have to agree with both. So network automation is a critical area here. We have performed a number of projects in the area of using machine learning and machine intelligence into radio network planning, into core network planning, into and into providing a superior quality of service. And the networks are becoming more complex by the day, both on a standard and a theoretical level, but also on an implementation level. It is, and the machines that you need in order to, and the tools that you need in order to manage that, they need to become more effective and more automated. And I think this is an area where I personally find it a very interesting area to see how we can, and I would extend it also. It's not only in the network level, but also what we're looking at is when an application developer designs an application, they can't make it specific to a particular network. They have to be able to say, this functionality has the following compute and latency requirements. This part of the application has different latency and compute requirements, and that the network or the API itself works out itself how to distribute that across the various locations, device, edge, cloud, and that this is relieved from the. So I think this whole area, managing complexity in the face of providing superior quality of service, I think this is a good area for research. Yes.
Great, thank you so much. John?
Yeah, I think, first of all, yeah, excellent point so far from Bo and Derek. And I think I would agree that one of the interesting aspects is then how are you partitioning, even if you're looking end to end at the performance, say, of compute for something like augmented reality or virtual reality, where we may have some processing on device, some processing at the edge. And so when we look at the scalability, as Bo was mentioning, how do we ensure that the 5G networks, as they're getting deployed, so consider, a 5G private network going into a hospital, going into a factory, going into a school, where you're making sure that there's the aspect of security is provided, and at the same time, mobility within that environment. And then we also look at the reliability focus. So some of this obviously is already supported in release 16, but then when we look at the research topics heading into release 17, 18, 19 into 6G, I think a lot of interesting research will be on some of this cross-layer optimization, and then also on the fact that we're really looking at how to enable machine learning and interaction with wireless in a more foundational way. So imagine the sort of messages that are exchanged now between devices in the network, the optimization of the network, the optimization that is becoming more key to really enabling some of these applications. So I think a lot of good discussions on the aspect of latency and energy consumption and power consumption, and then how that feeds with the role of edge compute and where that compute is actually occurring. And so when I look at that intersection of power consumption and latency as enablers for these use cases, then all of a sudden, core foundational research into the best way to use spectrum and to ensure this connectivity is matched to the needs of, say, a particular application. Maybe it has periodic video bursts at a certain rate, or maybe it's something where in terms of the overall processing fabric, there's some burstiness or some predictability to that communication. So then we would want to make sure that the air interface, how it's doing its scheduling between the device transmissions, the network transmissions, the topology of the network in terms of device-to-device communications, or even what we call integrated access and backhaul, where the network is leveraging wireless technologies either on the backhaul or the front haul. So the interesting part of the communications and computation fabric, I think that continues to be a very important area of longer term academic research, because that's what's going to enable this scale, and then also enable true performance differentiators that are going to take some of these use cases from being non-feasible to being feasible. And I think as that research is happening, it's also important to keep an eye on then the scale of the deployments, and whether it's an urban market, a private network, or a rural market, how to ensure that those similar techniques are adapting across frequency bands, propagation needs, and those coverage aspects.
Wonderful. And since Qualcomm has lots of innovation on the physical and MAC layer, what kind of challenges and opportunity do you see there?
Yeah, on the physical and MAC layer, we still see a huge need to focus on communications reliability and then also the scalability of using different frequency bands in creative ways. So if we look at volumetrically at the amount of data that's being produced, and that's the interesting aspect of 5G and AI, it's not only about the fact that, hey, AI needs data, so there's going to be more AI processing on the network side and the device side. It's also the fact that AI itself is creating data, and it needs to exchange that data and move that data. And so when we look at FiMac and these sort of data transfers that are required to enable distributed AI and things like federated learning, so that the optimizations that are device specific, network specific, frequency band specific versus more general long-term optimization, I think that's a very important area of physical and MAC layer research, is these aspects of then putting it all together end to end, so that the communication link that is between the transmitter receiver endpoints is part of this broader framework on what we call the multi-user, multi-cell, overall, what I call the volumetric aspect of the data exchange in either direction. And so the physical and MAC layer research, whether it's modulation, coding, transmitter efficiency, I think also a lot of physical layer design now needs to be relatively specific to the frequency band. So things like optimizing transmit data paths all the way to the antenna in terms of the power amplifier and the RF nonlinearities and ways to improve that with sophisticated processing. So it's something where on the link side, and then on the network side and the scheduling side and the spectrum sharing side, there's still many important research challenges that lie ahead for the industry and for academia, because we're continuing to see this transformation of more and more use cases going on to 5G and longer term into 6G as well. And so because of that, core foundation of the academic research really needs to keep moving forward.
Awesome. Ganesh, would you like to share your perspective?
Sure. In many ways, I think, I would expand upon the points mentioned by both John and Derek. Is when we started off on video analytics, one of the key things we actually found that was a challenge missing and something we spent a lot of time building was being able to deploy these applications across these hierarchies of computes available, say, at the device itself, on like intermediate edge hierarchies in the cloud. And a key challenge there was being able to do this dynamically, in that network conditions change, sometimes things fail. I think Bo mentioned about reliability in his answer. So when this changed, being able to automatically move these components around, we saw as a big research challenge and a big concern to the partners that we worked with as well, in that how would this be running throughout. So I think that being able to develop a platform for any application, not just video analytics, any application where the platform will do this splitting automatically and also dynamically manage and move the components around is a pretty challenging and a nice research opportunity. One thing we've seen, especially in the context of say machine learning applications, is that an opportunity is this trade-off that we have between the resource usage and the accuracy of the outputs. In that, unlike some of the other applications where the resource demand is sort of fixed and you have to work with the demands that is presented to you, here you could say that, hey, you know what, suddenly I'm in a crunch, I'm going to run a more compressed model for the next 3 seconds. The accuracy is going to be a little low, but at least it'll be there. And so, of course, we'll have to meet a certain minimum level of accuracy and so forth. But this is a pretty nice sort of like ace in the hole for both computer optimization, network optimization, this resource accuracy trade-off. So yeah, that's sort of like something we've used a little bit in our research, but I think that can also be generally a pretty nice characteristic to employ.
Very interesting. And while 5G is still being rolled out in most of the world, it's never too early to talk about 6G. What do you think will be in 6G? What kind of killer app there, and what opportunities and challenges will 6G create? Derek, would you like to start?
Let me go first. So there are lots of. So I think this is. There's a lot of questions here in one. I think if we look at the, again, the kind of people, the companies that come to us and ask us to do to develop things in this, we're looking beyond what you can get from standard 5G vendors. So, and we are getting a lot of questions on the development of advanced antenna systems, which go beyond the capabilities of massive MIMO and phased arrays that that are standardized in 5G. So I can see that in the so that's clearly one area where I can see the and even more efficient use of the air interface resource and and even more gaining even more capacity from that. So I think that's one clear area. I mentioned non-terrestrial networks as well, and I think that's also but I think that will be solved before we get to 6G. In terms of then the applications that we see for 6G, I think it's an interesting thing. So one way to look at that is the technology push, to see what the technology enables. The other one is to see the market pull and what the market would like to have. And these two they go hand in hand. They're not separate, because sometimes the market doesn't know what's possible until the technology says what's possible, right? So they kind of go hand in hand. And I think so. We are currently locked into a cycle where the devices that we've got, which are primarily smartphones and smartwatches and some other devices, but let's say it's the smartphones are really the tablets and laptops are maybe the main devices. These are becoming very powerful and very expensive, right, at the same time. And I think there is quite possibly going to be a fragmentation in this, where there will continue to be the need for high-end devices like this, but there is going to be a fragmentation that more and more devices are going to become user equipment. So the obvious one is the automobile. That's clear. That is, it's almost there already. There is so much intelligence and so much software in cars, and and so on. So that there's going to be but then there will be other things as well. So even kind of relatively straightforward consumer devices that you may not have thought of before as being equivalent to user equipment are starting to incorporate some form of intelligence, so then and this is where the edge compute angle comes in, where you want to have a low-cost device. So you want to have a low-cost device, but you want to have intelligence in it, and then you have the intelligence in the edge and the link, so it appears as if that intelligence is in your device. So that's more kind of some points on the technology push. On the market pull, I can't help but feel that, particularly with COVID-19 and pandemics, and I heard that today a meteorite passed so close to planet Earth that it came inside the orbits of satellites. Right, so it's really, I mean, this is very close. So there's other kinds of natural kind of things that can happen. That disrupt our way of life, and I can't help but feel that there is that these things are looking for companies to become more resilient and more flexible and more dynamic, and at the same time, also we as private individuals are looking for the same thing. And I think to take the private individuals, what that means is that we want to be able to be in other places without actually leaving our home, for example, or our office. So there is augmented reality is clearly that we can have a more immersive experience, but that's a very visual thing. So what about the other senses, right? So, and in particular, I'm thinking about haptics there. Well, I think in the first instance, haptics really. That and the combination of haptics with sight and sound and the other senses, so that we can. With virtual reality, we can put ourselves in an orchard, for example, but with haptics, we can feel the bark on the tree and we can see whether the apple is ripe, as well as just seeing this kind of thing. So we can be in that the concept of place becomes redefined, given all these things. That's sorry, so that was a little bit longer than intended. Sorry.
That's amazing future. We really look forward to. John, do you have additional thoughts?
Yeah, I think that I also agree that there's an aspect of you look at the state of technology, say in 2030, and what's going to be possible. How can we combine new advancements together in a revolutionary new air interface? And so, what will be the state, just as we're talking on this panel, of cloud, edge, containerization, the notion of distributed cloud in the time frame of 2030, the state of machine learning in 2030. The role even of new materials, metasurfaces, bands like terahertz. What is the role of energy harvesting? Even the role of human-machine interface. I think the aspect of biology and how we're able to augment people, whether it's their eyesight, whether it's their hearing, whether, as we're talking about the human-computer interface, I think that's absolutely going to continue to evolve. So today we have our laptops, our tablets, our smartphones, we have our headphones, we have wireless earbuds, and we look at the evolution of all of those form factors and where computing is, and then also when do people want to be hands-free. And when I look very long-term at the role of augmented and virtual reality, I think we're in the very early stages of that technology and how then it gets deployed in a wider area setting. And so I also look then at the aspect of what I viewed as kind of the physical world. So these are the devices that we have today and the way these devices are going to evolve. So absolutely, we're going to see more types of devices. We're going to see more types of how those physical devices are, forming networks. How are they themselves even cooperating with each other for things like positioning or ranging? Look at the role of where you need to actually have accurate positioning in addition to communications and compute for the actual use case to make sense. So good examples are obviously autonomous driving. Other examples include ground robots, but then even things like augmented reality, you want to have understanding of the pose, the position, where the person is. And so that physical world is also being digitized into the digital world. And so in terms of the time frame of 6G and the physical world, the digital world, the virtual world, I do see this intersection getting tighter and tighter, where the digital world, in terms of where the data is, how processing is occurring, where is data able to enable workers to be more productive? We look at the aspect of what does a hospital look like in 2030 versus 2035 or 2040. And so the role all of a sudden in the communications and the computing, the way the equipment can interact, the way the data is processed, what's happening at the edge cloud versus what's happening within a range of devices. And I think the virtual world, as I mentioned, is also really going to continue to evolve substantially. And that's really going to affect user interface for people. And so this kind of physical, digital, virtual world and that merging, in my view, is going to be one of the core bases of 6G. And you're combining that then with the technology state of the world in 2030, and then the role for a powerful new air interface to leverage these technology advancements. And then also the supply and demand side of new use cases, connecting a wider number of people across different cost structures, across, not only providing, data buckets of connectivity, but also some end-to-end service optimization. So I think it's an exciting time for, as we're pushing the boundaries of 5G into, release 18, 19, and 20, and then looking at, okay, which of those technologies can be combined in a more interesting way into a brand new air interface, namely 6G. So I think it's about how things get combined, and then also some of these distinct use cases.
Awesome. And there are more questions from the audience. Naria Gordian asked, what will millimeter wave bring in 6G that it doesn't exist in 5G? Do you think we will have a huge breakthrough in 6G so that we will make lots of application for field? John, you seem to be a perfect person to answer this question. Would you like to start with that?
Yeah, so we're so absolutely millimeter wave's already deployed with 5G release, 15. I'm holding in my hand here a 28 gigahertz, 39 gigahertz millimeter wave device, and it's something where when I look towards continuing to improve things like mobility, the way that the devices can interact with each other, interact with the network, and so the communications in the millimeter wave bands are absolutely going to continue through 5G and into 6G. And obviously, even in 6G, we will be looking at sub-terahertz and terahertz for certain interesting applications, not necessarily in a wide area compute in terms of the propagation. And so millimeter wave there's such a large amount of spectrum, and how we're able to bring new bands into providing coverage. So the interesting thing about cellular technology evolution is the aspect of spatial processing, bandwidth, bands. So going higher in band, more directional, and leveraging the advanced processing to enable mobility at these faster switching times. So that's core to increasing the overall communications capabilities. And then it's being done in a more and more energy efficient way because the energy is being directed, to where the devices are. So it's a more efficient use of spectrum as well in terms of the spatial reuse. So you can, what we call cell split, or add more cells. Cells can be adaptively forming. You can basically evolve the network in a faster cycle of compute. And I think machine learning is going to play a key role there in some of these self-organizing millimeter wave networks. And so longer term, I think all of those vectors of improvement across mobility, topology, when do you have a smart repeater? When do you have a smart surface doing the reflection? How are you able to combine multiple antennas on the network side and multiple antennas on the device side in more and more intelligent ways? And so what's the best way to use the spectrum in a power efficient way? And we look at, things like performance per watt. We look at, energy per bit. And so the role of power consumption, energy consumption, and that end-to-end connectivity. So I think from a semiconductor standpoint, there's going to be continued advancements in PA efficiency and those sorts of things. And then all of the baseband, FiMac, topology, even things like security, really taking a broader term look at all of those 6G capabilities. And then I absolutely think that there's going to be a continued heavy focus on making all the bands more useful. 6G is not just going to be about, say, very, very high frequency terahertz bands, but there will also be the aspect of evolving what we're able to achieve in existing bands today.
Wonderful, thank you so much. Ganesh, would you like to share your thoughts on 6G application, how 5G, 6G can support holographic communication? The last part is a question from Hisham.
Sure, yeah. So I think with 6G, we would, I'm sure we'll have, definitely the applications that we are excited about with 5G in terms of more video streaming, IoT broadly, AR, VR. And I think 6G would quite likely enable the quality of the experience of these applications to a level that is dramatically higher, and hence would sort of like make the adoption to be much better. So that in many ways, I think, is from the applications point of view. But of course, as Derek said, of course, applications and the technology go hand in hand. We can't predict one without the other. But in terms of what I did read, one thing that did, sort of like catch my eye and I really liked was this term wireless cognition, which essentially meant that, like right now, being able to transmit sort of like what we, sort of like what our, thought processes, so forth, are like human intelligence with zero latency over the air instantaneously. In many ways, I took it as the fact that we would have these access to this huge amount of AI capabilities, etc., that we need for a whole bunch of these cognitive assistance that is available with near zero latency. And that, in many ways, I think can be a game changer. But as I was thinking about it, of course, one thing that kind of like I think we should be cautious about is we are adding a whole bunch of bandwidth, of course, closer to the data sources in the last mile, so to speak. I think John mentioned about even terahertz band frequencies and so forth. But we have to be careful that we don't end up in this world where a whole bunch of bandwidth exists close to the data sources in the last mile, but a big bunch of the AI capabilities are still closer to the core of the network, because then that would sort of like become a problem. Being able to navigate this tension, I think, would sort of like be critical to realize the promise of 6G, and in some ways 5G too.
Great. And there are lots of questions, both from the audience and also from myself. But in the interest of time, can we have some last thought about the privacy and security, which is also a very important topic? Any quick thought about the privacy security capability in 5G? Is that sufficient to support the edge application they need? What new capability do you like to see?
I can go. I mean, I've heard a lot of the privacy sensitive applications with video. So yeah, I can see that. Definitely people view, even for people for whom, you know, going to the cloud, the bandwidth, etc., is well provisioned, not a problem. To them, they love the whole idea if we can get in edge computing as part of the solution, because that allows a certain control in terms of defining what goes outside their trust perimeter in terms of what data can leave and what data will have to be analyzed inside. So I think being able to combine, you know, sort of like nice sort of like compute capabilities closer to the data sources, especially for sensitive data like video, is a huge opportunity to ensure that we get the benefits of it, while at the same time we don't have to sacrifice our privacies. Of course, one thing, a challenge to note here is, or two challenges I see is, we need clear interfaces in terms of being able to define both the data pieces that are sensitive and the trust perimeters where it can go and cannot go. And the second is sort of like efficiency questions, in that the whole push or the whole attraction towards 5G is towards the fact that it's performance. So in getting the privacy, we shouldn't get to a thing where the overhead is high to a point where we might lose those performance benefits. So that's like a nice technical challenge as well.
That's great. With that, this concludes our panel. Thank you so much for the panelists sharing their insightful thoughts and vision of the future. And thank you everyone for attending the panel.
Thank you.
Thank you, everyone. Thank you very much.